Today I'm going to show you how the Lexus all-wheel drive system works. Here I've got an A760 transmission attached to an all-wheel drive transfer case, and this is out of a 2007 Lexus GS 350. And no, it's not out of my Lexus GS 350 because this one is rear-wheel drive. Now this is the all-wheel drive transfer case where the front prop shaft is going to connect over here and the rear prop shaft is going to connect over this way. So we'll tear down the transmission in a separate video, but let's get this transfer case off and see what's inside these guts. Got a brand new Milwaukee battery for Black Friday. Let's see if I can get this axle nut off easily. Pull this flange off. Oh shoot, it's gonna leak fluid. All right, around the back here we got a bunch of 14s to hold the case on. Funny, I turned over the transmission. There's a transmission pan and then there's a transfer case oil pan, so let's take that off next. That's the valve body that controls the all-wheel drive. There's a little valve body, and you can see there's one solenoid, and that's going to control the pressure to the clutch for the all-wheel drive setup. Alright, so I'm going to get this bolt out here. It's 14. Alright, so this tail housing kind of slides off here, and this has the valve body attached to it. Alright, next up it looks like we've got a planetary gear set. This whole thing is an assembly, and we'll discuss this in a bit. And the reason why this wasn't splitting off the transmission is we got a couple more bolts here. They look like 12s. Alrighty, hopefully the transmission doesn't toggle over that way. Pull off this transfer case. Who knew you had to take it off in pieces? So here we've got the output from the transmission itself. You can see that it's got this flange on the outside that's held in by a couple more bolts, and that's why this transfer case doesn't just fall off as one piece. Now, these look like 14s. This is the output of the transmission, and that's going to go directly to the planet carrier inside of the transfer case. So let's take a look at that next. So here we've got the transfer case all taken apart here. The transmission output shaft is going to run through the transfer case over here, through the section here that has the chain on it, and into the back where we've got the planetary gear set. Now that transmission input is going to go directly to this planet carrier inside of here. The rear is going to be powered by the ring gear, while the front wheels are going to be powered by the sun gear, which goes to the front here with the chain mechanism. Now having a center differential is ideal because you could have different wheel speed differences between the front and the rear. So for example, if you're going around a corner or if you're doing a really bad burnout, you have that wheel speed difference that can be taken up by this differential, and there's no binding in the drivetrain. Now the key to this one is it's kind of a locking differential because it can vary how much torque is transmitted from the rear to the front. And as you see, you've got the sun gear from that planetary gear set, and that's what's going to power the front wheels through this chain mechanism over here. But we've also got a set of clutches in here with a piston that gets powered by these little holes over here that sits on this flange. Now let's say, for example, my front wheels are locked and I'm doing a burnout. I'm turning the planet carrier, which is the input from the transmission, and that's going to only turn the ring gear, which is my rear wheel, so I've got my rear bias. Now that torque bias is only there because this clutch is unlocked. Once I start to take this apart here, you'll see inside of these teeth here are splined to the input of the transmission, which is planet carrier. As I apply pressure from the piston of the back here, this clutch is going to start to lock up slowly, and that's going to lock that planet carrier to my sun gear. And now all of a sudden some of that torque that was going to the back is now being transferred to the front wheels. However, these clutches are designed to slip. They are bathed in fluid, and you can regulate the pressure that's inside of this piston, and that's what will give you a ratio of 70 to the rear and 30 to the front depending on the driving dynamic, and that's all controlled through this solenoid over here. So just to clarify, our 70 to 30 front and rear gear split is determined more by the gear ratio inside of the center differential between the ring, sun, and pinion gears. That clutch is going to lock up to give torque to the axle that had the most traction. Now I'm going to remove this planet carrier here, and you'll see this is the input coming from the transmission. Now one thing I do notice is that it's kind of burnt on the outside here where it plugs into that clutch, so let's take a look at this next. Let's pull off this snap ring. Here you can see this is the piston. It's held in by a C-clip on this side and this side. And the rightful way to take this out would be to remove the C-clip and put some compressed air in here. Now how these clutches work is we've got these bands which have these teeth on the outside. That locks to the casing over here, which is the sun gear. And then we have the teeth on the inside here with these friction discs. That's going to lock to our transmission's input. And normally these are going to be slipping around in transmission fluid when you have that wheel speed difference. Now once you start to apply fluid pressure over here, you're going to squish them together, and that's going to lock that sun gear to that planet carrier so you can have that even torque transfer. Now the condition of these are mild. You can see that the friction friction bands do have quite a bit of wear on them. They are a bit darker, but I wouldn't say they're completely burnt. I don't see any heat spots or anything. Now if these were burnt, you can definitely tell someone's been doing some burnouts in their all-wheel drive Lexus GS, because these can't handle an excessive wheel speed difference, especially if the skid control ECU tries to kick on and squish this together, while at the same time you're hanging on to the brakes of the front wheel. Now this piston has a couple of holes in it that's going to activate with the pressure of the fluid, and that's going to sit onto this flange over here. And the back side of that is going to feed this giant chain, which goes to plug into the front prop shaft. Now this chain does not have any tensioner on it, but it is bathed in fluid. Interestingly though, it's got this little flap door where it can share fluid between the planetary gear set side and the chain side. Now if we take a look at the hydraulics of this clutch over here, it's got the holes to activate it. That correlates to the holes over here on this flange. You can see there's also these two seals on the outside there, and that gets its fluid through this hole over here, which correlates to this hole and this one over here on the transfer case. Now the second hole over here is actually the supply, and that comes from the transmission on the back side of this casing over here. Now if you remember, that planetary gear set sat in this tail housing over here with this valve body. These are the two holes here for the supply and activate, correlating to the supply and activate over here. Now this little terminal leads to the two prongs on this solenoid over here, part of the valve body. So let's open this up. Okay, let's pop this valve body open. Plate in the middle, just like any other valve body. This feels so buttery smooth. So there's kind of three valves over here. This is the solenoid part. That's going to activate a hydraulic circuit. Then we've got two other kind of controlling valves. You can see if I squish this here, there's some fluid coming up through here. It's all activated through spring pressure, so it allows the correct amount to go to the clutches. You don't want to apply too much pressure or too little bit pressure. And they've calibrated this to have the correct pressure according to the voltage that's applied. And because this little valve body sits over here, it's got the two lines, supply and activate, and that's going to correlate to the two lines over here. There's even a little inline filter. This one's whistle clean, of course, probably a low mileage vehicle. I find it very interesting that we've got a full-on valve body inside of here to control one clutch in the transfer case. Finally, we've got the chain on the front here, and this is just like most other transfer case chains. It's a straight cut gear, so I can imagine this thing might make some noise. It's worth noting though that there's not always a huge wheel speed difference in the center differential, so this chain is always moving anytime the front wheels are moving, and the front wheels are generally moving every time the rear wheels are moving, so this whole thing is normally spinning together. Now the GS350 has VDIM, which is a vehicle dynamic control system, so the four-wheel drive is not just limited to whichever wheel doesn't have slip. It's tied to a whole bunch of other things, like all of our wheel speeds, our throttle position sensor, our steering angle, the instrument cluster, the engine control module, and our skid control ECU for our traction control. That's all fed into our four-wheel drive ECU, which then controls that solenoid on the transfer case to control the torque split. Even though mine is rear-wheel drive, this car will literally steer you out of a skid. It's so controlling, just like pulling a dog's leash. And that's a look at the all-wheel drive system on this Lexus GS350. I think it's a little interesting to have a full-on tail housing with a valve body and a transfer case pan, kind of like a mini transmission, just controlling one clutch. The Infiniti and Mercedes systems are laid out a little bit more simple. Anyways, make sure you subscribe if you want to see more videos just like this one.